So hello guys, you are welcome to another video of mine. Today is the 20th day of our UTMA and SSE preparatory class. We are now in the topic of electrical cells. This video covers our maximum in-depth of knowledge in minimum possible time. For those of you who are new to this page, you can go through our video lessons, and if you are preparing for UTME or SSE, I would suggest you start from the first one. We have a playlist for all the videos that we've done so far so good. Like I said, all topics of your physics will be covered from head to toe, and after all is said and done, I'm going to do a general mock test, which is more like the kind of examination questions you are going to see. So invite your friends, and if you are watching for the first time, if you find anything interesting at the end of the video or after watching the video, you can consider subscribing to this channel. Let us start with the topic of electrical cell. Like I always say, your pen, your notebook, or your jotter is one of the most important things to put down all what I'll be saying, because I'm going to be taking you through all what you might have studied before, and I'm going to be adding a lot to what you've not heard before. That is guaranteed. So let's start. The first question. The lead acid accumulator consists of that. Let me be quick to explain to you when we talk about the concept of electrical cells. Now, they are classified, basically, you call it battery or chemistry, into two. I hope we are writing. Primary cells and secondary cells. Let us put that down for the first one. Now, we saw basic difference. Primary cell cannot be recharged after use. Apologies if I'm rushing. While secondary cell can be recharged. Now, to understand how it is being done and examples, we have a lot of examples. Example of primary cells are the voltaic cell. We have what they call galvanic cell. Your knowledge of chemistry will have explained all this. We have Whiston cell, and we have the wet and dry Leclanché cell. I'll put that here, Leclanché cell. All these are classified into the primary cell. Why are they primary cells? Because the PD, potential difference that they can generate, is always less than 1.2 volts. Please note that. The amount of potential difference they produce, that is the light they can generate, is between 1.0 to 0.2 to 1.2 volts. Now, whereby the secondary cell that can be recharged after use, we have quite a lot of them. Example, the major one is the accumulator. Basically, accumulator is what your syllabus require. Accumulate. Permit my spellings. So example of the accumulators, we have the lead acid accumulator. The way it is being written in junior classes, lead acid accumulator. We have the NIF, which is called nickel ion accumulators. So this is the basic thing. Now, how is battery made? A little bit of your chemistry knowledge is going to be tested. Now, let's use the chemistry concept knowledge. Let's increase the brightness of this. Now, from chemistry knowledge, you know, there is always two compartments in cells. Let's start with the primary cells. Most of your primary cells, are you there, consist of copper. That is what? Copper anode, that is the positive, and the zinc cathode, that is the negative electrode. This is called electrode. A little bit of chemistry, I said, electrode. So almost all your primary cells use copper anode and zinc cathode that is dipped in H2SO4 electrolyte. I said we're going to talk about a little bit of our chemistry. So most of the primary cells use copper anode and zinc cathode that is dipped in acid electrolytes. I hope you are there. Now, the only one, the exception, that is a primary cell that doesn't follow this is the Leclanché cell. I hope I'm talking. What you learned in class for 3 weeks or 2.5 weeks will be taught in most the academic page under 45 seconds or under 45 minutes. That is the importance of coming here. So please keep that at the back of your mind. Leclanché cell, exception. They use carbon as their positive anode and zinc in their what? Negative anode and negative cathode. You can see that's the only one that goes against other types of primary cell. Then they are now dipped into manganese 4 oxide as their electrolyte. I said manganese 4 oxide, not my ammonium chloride. Sorry about that. Apologies. They are dipped into NH4Cl. NH4Cl as their electrolyte. So keep it at the back of your mind. So these are basic things you need to understand. They're talking about secondary cell. Now I told you they are the accumulators, which are lead acid accumulators or the nickel ion accumulator. About the lead acid accumulator, let's talk about their anode and cathode, just as we have talked about this. Now, the positive anode, which is for accumulator for lead acid, it contains the lead hydroxide, PbO2. And the what? The negative cathode contain a what? Lead, which is dipped in what? H2SO. Whereby nickel ion, you can see from the name, nickel slash ion, dipped in what? Alkaline. Any alkaline you can talk about. You know what for alkaline? Potassium hydroxide, potassium chloride, sodium chloride, any alkaline you can talk about. Alkaline are base. Potassium hydroxide, chloride, and sodium hydroxide. You know, alkalines are soluble base, the way you call it in chemistry. So that is just a summary of everything. You can see what I've said. The primary cells can be recharged. They can only produce what potential less 1.2 volts, and because of that, they do not what they cannot be recharged after use. Secondary cell can be recharged. Examples are accumulator. Most primary cells use carbon, copper, and zinc that is dipped in H2SO4, except the Leclanché cell. You can see the way I'm wrapping because I have written everything for you, which you can put that. So now, I think this question has answered itself. When we say next question, we are going to talk about some other concept that is needed. But if I continue to talk and talk and talk, there's always what I will say. But I only want to limit all questions with respect to your syllabus. This question now says, the lead acid accumulator consists of that. Let's start. Lead as the positive electrode. Let's go. Positive electrode is not lead. Positive electrode is lead hydroxide. Negative electrode is, you can see, is what? Is lead. So this is wrong. Lead oxide, it's not even lead oxide, it's lead as hydroxide. It's wrong. Hydrochloric acid is wrong. Look at this now. Tetrasulfur 6 acid as electrolyte. Look at the electrolyte. H2XO4. This is the right answer to that question. It's very direct because I have taken you through the concept. I believe we can move on. The next question. Which of the following has the lowest internal resistance? Now, let us define that because we are in cells. Before we go to electricity tomorrow, by the grace of God, electricity is tomorrow. Then you are going to answer up to 20 to 25 questions because it's wide. Excuse me. Now, which of the following has the lowest internal resistance? Let's define internal resistance. Internal resistance is defined as the resistance offered by electrolyte. By electrolyte. Resistance offered by the electrolyte to the motion. I'm giving you my own definition. My book will soon be available for you guys to buy. Don't worry, by the grace of God. Now, resistance offered by electrolyte to the motion of gas in a cell. Now, what do we call resistance? That is just the first thing we need to understand. Resistance is called opposition to the flow of current. Basic way. Normally, opposition to the flow of current. So by word, what I'm saying is that if resistance is high, current is going to be what? It's going to be low. we denote internal resistance as small letter R. It is inverse. That is what I'm showing here. This is external resistance, we call resistance. When we write small r, we now call it internal because it is produced by what? Ele. So the nature of the electrolyte use affects the type of current or the PD that is going to be generated in the cell. So if the electrolyte is not that good, that means the amount of current or PD that is generated is going to what? Is going to be affected. So when resistance is high, you expect low current or low PD. Always keep that at the back of your mind. So keep that at the back of your mind. Now, to answer this question, we need to understand what we need to go back to what we have talked about in the first question. Which of the following has the lowest resistance? The one that has the lowest internal resistance will produce the highest voltage or the highest current. I told you primary cells produce lower PD. Secondary cell produce PD that is greater than primary cells. So their own is between 1.2 and above. 1.2 volts and above. You can keep it, you can write it down. It's important. Now, if there is what? These are primary cells, but there is a secondary cell there. The secondary cell produce higher current, higher potential than the primary cells. Because of that, the answer we are going to take there is a secondary cell, because the one that we have the shortest or the lowest internal resistance will produce the highest current. Out of all these options, the one, everything here, this is a primary cell. Daniel cell is a primary cell. Torchlight battery is a primary cell. But accumulators are example of what? Secondary cell. So right answer, dear students, is choice C, and that is the answer to this question. I hope students are getting this. We move to the next slide. Now, about the next slide, we have a double fold question in one. The first one says, which of the following is an electrolyte? Let it be known. Chemistry student, electrolytes are inorganic substance. Electrolytes are inorganic substance. In your subject of electrolysis and electrochemical series, you might have studied that. So inorganic substance are majorly, inorganic substance, they are majorly acids, bases, and salts. Those are basic things you use as what? As your electrolyte. So it's kind of simple to know that the answer here is nothing but what you can see here. Which one follows is an electrolyte? Just go for the one that you think is what? An electrolyte. Alcohol is an organic compound. Alcohol belongs to the families of alkanols. I hope you understand. Now, paraffin also is what? Is an organic compound. I'm helping you to actually break it down. Now, let's take this. Sugar solution, which you think is the answer, right? Sugar solution. Sugar is also what? An organic substance. Hope you know. Sugar is a carbohydrate. I hope students know that. Sugar is written as C6. This is glucose. H12O6. I hope you know that. C12, H22, O11. This is sucrose. I hope students still remember hydrolysis of salt and hydrolysis of sugar. This is sucrose. Chemistry, God willing, when I'm through with physics or chapter, I am going to take all chemistry chapter from A to Z as well. So God willing, by the grace of, the only thing I won't be able to do is the maths chapter, because I'm not sure I'm going to meet up. The only thing I will do for math students is I'm going to do a general mock test in series, which will cover all areas. Math is very simple to pass, to be honest. So the answer to this is nothing but what? A grape juice. A grape juice is more like an acid, which you guys know very well. You call it, I think, ascorbic acid. I hope you understand in terms of understanding that ascorbic acid. Let it be known. So organic compounds are not used as electrolytes. You keep that at the back of your mind. It's a twin or double question in one, two-in-one question. The next question says, which of the following chemical is used in a simple voltaic cell? A voltaic cell, it's a primary cell. We've discussed that. In a primary cell, I told you what we use as electrolytes in the primary cells are what? H2SO4. Exception. Exception is what? Leclanche cell, which use carbon and zinc, that is dipped in what? NH4Cl. Let it be known. Very important, you know. So what's the answer to this? The answer is H2SO4, and that is what you are looking for. Where's H2SO4? Look at the way it is sitting here. Sulfuric acid is called H2SO4. let it be known, if you don't know it, there is always a first time to everything in this life. So sulfuric acid is H2SO4, and that is the answer to that. Nitric acid is HNO3. If you meet that, but nowadays, new pattern, I don't expect them to write sulfuric. You're going to see it as H2SO4. Mostly academic team, well done for this question. The next question. The next question is, local action is normally prevented from taking place in a simple voltaic cell by dash. Now, let me tell you that we are talking about, we said current is inversely proportional to resistance. For cells, we talk about internal resistance. For circuit, we talk about both internal and external resistance. We are still going to talk about that when we get to the topic of electricity, which some of you already had what you have an idea about the topic. Now, as current is being produced, I told you almost most primary cells use copper and zinc as their electrode that is dipped in what? H2SO4. I hope I'm here. Now, we said this is the positive and this is the negative electrode. Electrodes are pole, they are called anode and cathode. Oxidation takes place at the anode, reduction takes place at the cathode. Oxidation is loss, reduction is gain. These are shorty things you can keep at the back of your mind. Now, by and large, my dear student, what we are saying now is that here at this compartment, there is a problem we always face. The problem we call that actually degrade, when I say degrade, degradation, that is reducing the amount of current that is producing. At this compartment of anode, there is a problem with what we call hydrogen bubbles. Hydrogen start disturbing copper. You have learned this in the concept of electrochemical series in your chemistry. Remember, hydrogen and copper are very close to each other in the activity series. In fact, in electrolysis, your teacher will tell you elements below displaces the one above with respect to what? Factors that affect the discharge of ions. I hope I am communicating. I won't waste your time. Now, hydrogen bubbles affect this place because hydrogen is more stronger than what? Copper. Now, always now, hydrogen bubbles will take over this compartment. What's that compartment? The what? Anode. So when there's too much of hydrogen bubbles, this copper will now be shielded with hydrogen. Hope you understand shielding. That is, it's going to take over. So instead of what? The amount of current that is needed to what? To flow through this will now be degraded, will now be reduced. Let's use the simple layman language. I hope I'm communicating. And in this place, the same thing happens. Now, when there's too much of hydrogen bubbles at this compartment, we call the process polarization of cell. This is kind of different from the polarization of wave we have discussed under the waves and oscillation chapter. Let it be known. Now, polarization of cell is caused as a result of hydrogen bubbles at the anode compartment of your cell. It can simply be reduced by using what we call a depolarizer. Depolarizer. Now, at this compartment, we also face problem. The problem we face here is the problem of what we call local action. Now, what causes that? When the zinc here is not pure, when we use impure zinc at this, what's this compartment? Cathode. Now, as a result of impure zinc at the cathode, then we have an effect called what? Local action. So then, how can you reduce this local action? I turn to red. You use what we call what? You have to use a pure zinc, or what we call mercury amalgamated zinc. Basically, you are saying using what? Pure zinc. So that is that. To reduce what? To increase the efficiency of a cell. A cell means battery. To make it generate high potential, high current, all these things must be followed. You must reduce polarization at the anode. You must reduce what? Local action at the cathode. I hope I am communicating. So let's answer this question from the quick concept I have broken down into pieces. Let's check. Local action is normally prevented from taking in a simple voltaic cell. A voltaic cell is what? A primary cell that follows this principle. It is not Leclanché cell because Leclanché is always exceptions of all primary cells. Now, moving on, we say introducing an oxidizing agent to the house. I never tell you that's how to reduce local action. Not drawing current continuously for a long period of time. It is incorrect. Amalgamating the surface of the zinc plate. I hope you can see. So how do we reduce local action? By using what? Mercury amalgamated zinc. and this makes this answer to what to be valid. So guys, we move to the next slide. The next one is, I think, a simple, this is more like what we did now. A simple cell with mercury amalgamated zinc prevents what? We just talked about this. Answer is what? Local action. I hope I can move. Which of the following component is not found in a dry cell? Please, when we say dry cell, we mean what? Leclanche cell. I have given you concept. Please, a Leclanche cell consists of carbon that is dipped in what? Zinc. And the electrolyte is what? Ammonium chloride. Let me be quick to let you know. This is Leclanche cell. We've talked about it. Now, to prevent, this is the positive and this is the negative. At this cell, we talk about hydrogen bubbles. Now, to prevent the flow of hydrogen bubbles, we dip this carbon. Let me talk about it now. Now, that is to prevent what? Polarization in a dry cell or wet cell. Either you see dry or wet. A dry cell is called a what? A dry or wet cell is called a Leclanche cell. Now, a carbon is dipped. The carbon is dipped with what? With what? The carbon is dipped or is mixed with a catalyst. It's dipped in what? The catalyst we use is manganese. Manganese oxide is generally a catalyst. In the preparation of oxygen in the laboratory from decomposition of KClO3. You should know this. You use what? Manganese oxide as a catalyst to give you KCl plus O2. The balance equation, 3 twos and twos. The equation is balanced, take it to anywhere. That is what I'm talking about. So manganese oxide is used as catalyst to speed up the rate of chemical reaction, which you have learned in your basic chemistry knowledge. Now, when you are here to learn a lot of things. That is why it's always advisable to watch this video to the end. Now, back to what I'm saying. Carbon is dipped in what? Manganese oxide to prevent what we call hydrogen bubbles, polarization. The effect of hydrogen bubbles is called polarization. You can see the only type of primary cell that is different from other type of primary cell is what? The dry cell, which is called what? Leclanche cell. You can see if this other cell, they use copper and zinc and H2SO4. Whereby this one use carbon and zinc. Please keep that at the back of your mind. Now, let's answer this question now. Which of the following components is not contained in the dry cell in a Leclanche cell? Carbon rod. You can see there's a carbon rod. This is there. Paste of manganese oxide. What do we use it to do? To reduce polarization is there. Zinc case. It gets zinc. Zinc is there. Copper. Is there copper in this Leclanche cell? No. So this is the answer to our question. Please be careful about question on dry and wet. Now, the electrolyte, if you want to get dry cell, you can use yam flour instead of using what? Ammonium chloride. These are shorty things you can learn within minutes. Physics in minutes. That is our next title after we are through with examination for UTME and SSC students. We talk about physics in minutes. We are going to give you one of the best quality you can see around the country. Let's move to the next question. The next question. Next question say, which are the following? I think this is the same question I answer now. I think so. Which we pick copper. So that's the answer to that. Was the academy team are sleeping on bike? Let's note that they are sleeping on bike. Next question. The next is a function of the system of carbon. Look at this. What I talk about, carbon mixed with what? MnO2. I told you. See, what is MnO2? Manganese. Carbon dipped in MnO2 prevents what? Polarization. In what? In the Leclanche cell. Is to what? Look at it. Increase, prevents local action, make the cell of the good order, prevents. You can see what's it? Answer. You can see the way to click answer when you know concept. Answer is very simple to click when concept is what? Demystified. Next, guys. Which of the following can be used to reduce local action of a Leclanche cell? Now, imagine what is local action is the second compartment. That is the zinc compartment. What do you use? The same process. That is by what? Using what? Pure zinc or mercury amalgamated, the same thing. Pure zinc as the negative. Please be careful. But this is positive, right? And this is what? Negative. So what's the answer? Pure zinc as the negative what? 4. How do we reduce local action? By using what? Mercury amalgamated zinc. which is what? Pure zinc. We've talked about this. If you are still doubting, I can show you because it is here. See, mercury and manganese zinc or what? A pure zinc. I'm just showing you. I'm the one that I've actually written there just for you to see that I want you guys to follow us very well. So please watch this video till the end, or to the end rather. So answer to this is this. I don't need to read any other option. We are almost there. A dry form of Electrolytes slowly deteriorates even when not in use due to dash presence of zinc case, which is in line with absorbent paper, nothing like that. Internal chemical action caused this by the presence, nothing like that. Presence of hydrogen bubble form at the cathode. Where is hydrogen for bubble form? Is it at the cathode? Hydrogen bubble is formed at this point, positive. Where is the positive electrode? Is it the cathode? Presence of hydrogen bubble form at the cathode. That is where hydrogen bubbles is what? Polarization, but it is not formed at the cathode. Where is it formed? At the anode. Please note that. So now the last one, presence of depolarizing agent which oxidize hydrogen to water. That is the answer. I think now hydrogen bubbles has been oxidized to water. Now hydrogen combined with oxygen to give water. So instead of hydrogen bubbles, the presence of depolarizing agents which oxidize hydrogen to water. Let's read this question well. A dry form of electrolyte slowly deteriorates even when it's not in use because, yes, that is the answer. Presence of zinc is which is in line with absorbent paper. Internal chemical caused by all these are rubbish. Presence of hydrogen bubbles form. Hydrogen bubble is not formed at the what? At the cathode. It is formed at the anode. This is wrong. Now, presence of depolarizing agent, depolarizer, which oxidize hydrogen to water is correct. That is the answer. Because as more hydrogen is being what? Oxidized to water as you use the polarizer, the efficiency of the something what also decreases even when you are not using it because more of the hydrogen has been combined with oxygen to what? To form water. So what you expect is what? The amount of the current generated in there continue to what? Go down. And which means what? Deteriorate. So that's the answer to that. We'll move to the next one. I think there's the last section for this slide. And about this slide, because of piracy, that is why we are putting that. Which of the following factors has no effect on the EMF of a cell, voltage or current? Now, the EMF of a cell is affected by, we've talked about the temperature of the cell. Please note that. The EMF of a cell is affected by the nature of electrolyte or nature of electrode, both nature of electrode and the nature of electrolyte. But the EMF of a cell is not affected by the size of the cell. When we get to electricity, you understand, but because when we talk about size of the cell, arrangement of the cell might determine the type of EMF that will be generated for the size. So you can also put another factor that may affect EMF is the arrangement of cell and not the size. Let's keep that at the back of your mind. Arrangement of cell, because you can arrange cell also in series and parallel. If they are arranged in series, so we said the equivalent, look at the way we arrange cell. Listen to this, dear students. You can see the way I'm arranging cell. If cells are arranged like this, end to end, you can see positive, negative, you can see positive, negative, positive, negative. So if you have the cell of electromotive force of 1, electromotive force of 2, and electromotive force of 3,